Good morning, good evening, everybody, and welcome to the Ultra Low Power Wi-Fi Made Easy ARM Dev Summit workshop. My name is Chandra Duba. I'm working as the lead field application engineering in Dialog, which is now owned by Renesas. In this workshop, I will be presenting and working with you to show how our ultra low power Wi-Fi solution make the application development easy. And I also have Tour Nelson, who is our product marketing manager, and also Paulo Scarlata, who is a principal field application engineer, will be supporting us during this session. Okay, yeah, the whole session is segmented, have made into 3 segments. One is segment 1, where I will be covering the technical details of the 16200 introduction and the technology behind that. And then in the segment 2, we'll be doing hands-on workshop using our AT commands. In the segment 3, we'll be also doing hands-on workshop, but focusing on AWS IoT application. Okay, without further delay, let me introduce and give some quick information on 16200, DS16200, which is our industry lowest power consumption Wi-Fi solution. Okay, the DS16200 has been designed from scratch, targeting IoT and low power battery-based applications. During the whole SoC design, we have considered 3 key aspects every segment in every part of the chip. The one is low power, RF performance, and security. Under the low power, we achieve the low power using fast wake up and going back to sleep. And the second one is our ultra low power sleep modes. We have 3 sleep modes that we have. Sleep 1, where the entire chip is off almost, and there are few pins active. In this mode, we consume 200 nanoamperes. In the sleep mode 2, where we have an RTC block running, and we consume 1.8 microamperes. In the sleep mode 3, which we categorize that as a connected mode, means it's like a node on the network. In this sleep mode, we are consuming 3.5 microamperes. If you come to the RF performance, we haven't compromised the low power aspect by just compromising RF performance. We have a industry class leading Wi-Fi range as well as power. If you see that RF sensitivity, we have 99.5 dBm and the transmit power 20 dBm, which gives you a good link budget of 120 dBm and also covers a lot of range. Considering the third aspect, which is security, the device is certified for PSC certified, and we do support layer 2 security, something AES, TKIP, WPA, WPA2 personal enterprise, and the latest WPA2 security improvements, as well as WPA3 standard that is released by Wi-Fi Alliance. Considering the security aspect of the device, we do support secure boot, secure debug, and secure asset storage, which are key for a product. One of the recent achievement we had was we have been certified by Embassy, which is a benchmarking industry. I think it's international benchmarking organization, and it's actually given us a score of 815, which translates into 815 days of a sensor. That sensor is the standard use case they run across all other devices while doing the certification. Okay. In this here, I would like to share some of our SoC block diagram as well as some of the key features. You can find the block diagram here, and if you see the front-end module and the Wi-Fi radio, which forms the basic Wi-Fi system, we have ARM Cortex-M4F processor, which can run up to 160 megahertz clock, along with RAM, which can run actually user applications. We have a dedicated hardware accelerator, which accelerates the layer 2 encryption algorithms and also upper level security features such as HTTPS or TLS. The one thing that is not part of the SoC is the flash memory. Though we have inbuilt dedicated flash controller, we use external flash, and we use XIP to run the program out from the external flash. Like I mentioned, the whole chip operates in 2.4 gigahertz band, supporting 11 BGN standards. You can have the connected sleep currents also less than 440 microamperes. When I say connected means, I'm going to explain a little more in the next slide. It can run the whole chip can run the application hostless, means it can be self-hosted. It can run the user applications, or it can also interface with the microprocessor using UART, SPI, SDA, or I2C. Okay. Like I mentioned, we have virtual zero technology, which gives us the low power aspect, low power, industry low power in this, using this chip. So let me take you and then explain a little bit more about our sleep modes and how we achieve the low power. The virtual zero technologies enables multi-year battery life. In most of the application, we see 1+ year battery life based on the application use case, of course. The virtual zero technology consists of sleep modes and fast wake up and fast return sleep. In the sleep mode 1, if you see on the left-hand side bottom, which is colored in blue color, we actually, the whole chip is off except few pins where an external event can wake us up. We consume 200 nanoamperes, as I mentioned. If you see it on the right-hand side, while we are in the sleep, we consume 0.2 microamperes. And then when an external event comes in, we wake up quickly and then serve the purpose of posting some information over the cloud and going back to sleep. If you see the sleep mode 2, which is colored in yellow color, where we have an RTC block in addition to the sleep 1. So that's the mode we call it sleep mode 2, meaning you can have an external event wake up as well as you can program the chip to wake up irregular intervals and then do the activity. If you see it on right hand side, while we are in this sleep mode, we consume 1.8 microamperes. And also we can have both type of wake up, event-based one, which is the blue mark, and program-based or maybe an interval-based one marked as yellow color. In the sleep mode 3, where we categorize that as a connected mode, where we keep network time, network credentials, and it's like a node on network, like your mobile phone or a laptop. So in this mode, if you see it, we wake up at regular intervals and check for the incoming beacon and check for the incoming messages. We act on that. Along with, you do have program-based wake up as well as external event-based wake up. So it's kind of union of all sleep 1 and sleep 2. Okay. This basically you can map it to DTIM 1, DTIM 3, like if you compare with the other chipset vendors. Okay. With that details of our SOC's implementation and all, I will go to the next part, which is how we can make the whole implementation or development made easy. We have the full SDK, which supports many APIs and that support application development. One has to get knowledge on the APIs, one has to get the SDK knowledge and technology knowledge, which is a kind of complicated. So that's why we want to make the application development more easy. How do we make it? The first thing is reduce the hardware design by having a module. Okay, we have the module designed by us, it's owned by us, supported by us. You don't have any hassle working with third-party module vendor. If you see it here, it's the same SOC 16200 with the additional components such as a 4 megabytes flash and passive components such as crystals and few other inductor and capacitors. And it's also, again, since we use the same chip, it's a BZN standard as well as 1x1 2.4 gigahertz operation. The beauty of the module is it's been certified across all the regulatory domains across the world. So you have it's FCC, CEIC, name it, right? It's been certified across the world. And the size of that is also small, somewhere around 14 millimeters into 22 millimeters, which is very small if you see it here also. And as part of Dialog as well as Renesas, we support programs up to 10 years, which is a very good longevity. And with the module, we will have a seamless integration with host MCU also. Okay, the second part, how do we make even software development easy? We talked about how we make hardware easy by having module. Now we talk about how we make the implementation easy by having AT commands. Okay, AT command definitely make it easy because you don't need to learn about the implementation, software implementation under that. You don't need to know about Wi-Fi stack knowledge, and the module is fully certified that you can use. So we supply all those things along with a lot of documentation, example use cases, which is very easy one to implement an application. Okay. As part of the AT commands, we actually have so many AT command set. If you open our documentation, it's so many there. So, but we do cover most of the things as part of AT commands. We do cover AT command that support low power modes, enabling low power modes, connecting to the network. And also we have AT commands for Wi-Fi provisioning, which is very key, feature as part of any product. And also we also support many networking protocols as part of AT commands: TCP, UDP, HTTP server, client, MQTT, CoAP, so many things. So, and also we support AT commands for the area update and general GPIO configuration, where you can turn on, turn off GPIOs, you can read ADC readings, and also. And on top of this, we also supply the SDK. If you're interested, if you want to extend the AT commands, you can actually add your own AT commands, but you need to have the SDK, set the environment, and then add those functionality. Okay, that's how we think that one can make Wi-Fi application development very easy using our module and AT command set. Okay. Now I'll go to the next segment, but I would like to take 1 minute if you have any questions, or maybe you can send it over on the chat window, or so that our colleagues can answer them. Okay, going to the next segment where we will be starting hands-on workshop. Okay, here actually we are covering few things, which is number one is how do we set up hardware and software. Most of you might have received already the kits that's supplied by SparkFun and ARM. And also we will go through the AT command set, and then we execute generic AT commands and some example applications, which are very quick. And then we'll go to the next segment, okay? Coming to the hardware and software overview. Like I mentioned, you should have received SparkFun board and all these things, right? The SparkFun Wi-Fi Shield board, which has the DS16200 module, Pico board for the UART communication, Renesas MCU, cables, LED, and also like you should have a laptop running Windows. You should have an access point, a hotspot with internet, and one LED with a 330 ohm resistor. Okay, the connections are explained here. Hope this is also part of the pre-preparation information. So hope I expect you all have this ready and running. Okay, the key is make sure you have this RTC power key cable connected, because this will make the board running. Okay, going to the next slide, software setup. I mean, this is also supplied before so that we can save time. You should have the Pico board, driver installed on the Pico board so that it can become a UART interface. And you should also download the Teraterm. You should also download the IO Ninja and the pre-built images that were supplied. And also, I would like to inform you that there is a support forum on the Dialog Semiconductor website. You can also post anything if you wanted to know more on this webinar or workshop. Okay. The overall setup I will be using for this segment 2 to demonstrate some of our AT commands and example codes is like this. I have my laptop running Teraterm and IO Ninja, and like I showed you earlier, this is my setup. I will turn on my camera very soon. And I have my access point, which is connected to internet. So very simple setup to go and exercise our AT command set. Okay, let me start from here on my hands-on. So share my other camera. Okay, I'm sharing my other camera where I have my hardware set up here. So I have my Pico board, I have my SparkFun board, I have my LED connected, and my RA2L1 MCU board. Let's quickly start the Teraterm. And let me also show you that other connections, right? Just to make sure. So I have my things ready. The first part is let's update the firmware. plugging in my, okay, I switched on both of them. Okay, this is my Teraterm for the console port, okay? And let's start this one. In general, whenever we come to demo, always it troubles. So let me see what's going on. Okay, 2, 3, I have this PID 00. Okay, this one. Yeah, my 00, yes, this is the one. Okay. Okay. Since there is some loose connection, so. Oh, okay. What should we do? Let me take this out so that it may be better. Okay. Okay, let's keep it like that. That's better. Sorry about that. So, okay, right now I am running the one. So let's start the firmware update. So for that, you just need to call, I think you would have downloaded the zip file. Just call the macro file that we included, okay? I'm doing that part right now. So please give me a second. Okay, this is. I apologize for the little bit delay. It went into TPM power mode. Where the loose connections are coming in. Okay. Sorry about that. It has to come to that. Where is the loose connection? Okay, let me quickly connect them because there is some disconnection making it. Okay. I'll be running this one. Just a minute. Okay, apologies. I think there is some problem with my UART. Should I like started? Okay, what I will do is okay, give me a second. I may need to do this again quickly. Okay, I will pause it and then plug in something. Another board. I have another board which I will swap it quickly and then we can start. I think quickly. Yeah, I'm connecting my board again just to make sure it doesn't have any loose connections. Okay, I connected UART cables there. Meanwhile, if you have any questions, please do send it to Tour. And I hope everybody have the setup ready. That's another one. Hopefully, you also make it working, but I'm not sure. So please make sure you have your board up and running, and please follow the instructions that are there. This is done. Okay, this is done. Then okay, in this one, then Give me a second. I extremely apologize for this, but okay. Done. So this is done. This is done. Pickup is done. Okay. Need to have one ground cable. Okay. Okay. Let me see. By the way, I reconnected everything and it's working fine. So let me, am I sharing the screen? I think so, yeah. So what I did was I reconnected my board and let me also start my camera. Okay. I reconnected everything just to keep it separate so that we can plug in later. But as per the screen, the connections I made everything and it's working. I'm downloading the firmware, which is as part of the part one. Okay. Here. Okay, let it finish the download. Then we can go through this some of the basic command set as well as network command set. Then a few example codes. I also would like to see time check. So if you have time check, please let me know how fast or how much I should cover. Maybe we'll try to cover maybe a little bit extended time, but we'll see.
Yeah, we are running a bit behind, of course, Chandler. Actually, there was one interesting question here, which is very much related to what you've just seen. One of the panelists have had his board pricked, and I think maybe show here in TerraTerm where you're loading the TTL script to update that.
Mm-hmm. Yeah, am I sharing my screen? No?
Yes, you are.
Okay. Okay, so here is the one. I just downloaded everything, and you should see once you download, you should see this is the firmware ARM Dev Summit. Okay, and the moment it's on and running, so you should also see this is a console message. Of course, hello world 1 and UART 1 is enabled. So let's make sure this is the console. I'm going to start another one, which is our second TerraTerm. Okay. And I'm going to use that for UART 1 communication. Hopefully I have connected it properly. Let's see. Okay, I'm going to set it up to serial port and then 115200. Okay, this is too good, hopefully. Okay, lucky. Great. Okay, we are back on track and hopefully we'll cover quickly. So my boards were set up. Okay, this is what I'm going to demonstrate in this part is our module can work as a standalone, means you can run the user application on the board, as well as you can also just communicate using UART using AT command set. So I just supplied the power from the MCU board so that that's disconnected. And I'm using Pico board for the UART and AT command set. So we are trying to, mimic like you're writing an application and, sending AT command to the board and see the board is working. So let's start with a very big one, or maybe very major one, or I would say gives you all the information, which is help. Okay, I will type help here. Okay, it lists all the AT commands that are supported in this SDK. Okay, always you can have that in handy. And let us start with AT commands related to Wi-Fi. So normally the device can be in station mode, soft AP mode, Wi-Fi direct mode. So we have a command called AT Wi-Fi mode, which gives you the information on what mode it's running. So if you see it here, it's Wi-Fi mode 0 means it's a station mode. Okay, here also you can see in the console, it's saying the station only. Okay. Let's quickly go to another command. AT, you want to see the MAC address? Okay, you can get that MAC address also. It gives the MAC address of the station. Let's do a quick scan. Okay, WFS scan. Okay. Then it's going to perform some scan and then give you the result here. So if it's performed the scan very quickly and then provided the access point surrounding it. So I have seen mine. So I'm going to join my access point that we use that AT command WF join AP. Okay, and as you know, Wi-Fi has so many security modes. You should know the security modes. Most probably it's WPA to PSK. So I'm going to use my access point credentials here to join my access point. So that's my access point is moon and sun. Okay, and 4 is my security mode, and 2, and my password is 3562. Okay, the moment I put there, it took the credentials and SSID. It started scanning and associated. You can see it from the console that what's doing. Right? It automatically took it. It connected to the access point, got the IP address, and it's done. It's a node network now. It's connected. I can get the information by again seeing WFS stat. AT plus WFS stat gives me the information, what is my station mode or maybe status of my device. So it says station 0, MAC address, BSSID. This is the access point, BSSID. I'm using moon and sun, and then station mode. And it's I think important one is this one, WPS state, which is completed, means it's connected. Okay. Going to the next set of AT commands, I'm moving around the windows just to keep it clear for you. So let's run some of the network-based AT commands. Right? Once we got the access point, we can run or ask, what is my access network IP address? So AT plus network IP. Okay, I got my network IP address, which is 10.0.0.39 and subnet, and then my gateway address. Now I would like to add a DNS so that we can do a little bit network-based commands. Okay, AT plus network DNS. Network DNS equals 888. I'm going to use Google's one. Okay. Okay, it took the network DNS. Now I can basically get any network means any host translation means I can get an IP address of Google. Okay. Network host www.google.com. So that. Okay, this is the Google address. Now using DNS, we got it. Now I can do a ping and then see whether we are we can ping, and as well as we can access for internet. Okay, network ping. What I'm doing is its interface is 0 and the IP address is 142.250.191.68, and I'm sending 4 packets just to make sure. Okay, it's internally doing, it's a blocking call as AT commands does it, and it come back with a response saying that NW ping as 4415. So it's actually sent 4, received 4. This is the minimum, this is the maximum time, minimum time, and this is the average time. So, very simple AT commands. We have so many AT commands, but I'm demonstrating few here. Let's go to the next example. I would say example because these are like almost like application, am I right? Most of the times the devices are running either a TCP server or TCP client or UDP socket application. So it's so easy to run any of these things. It's a one command that can enable all the functionalities. So let's try first of all maybe we'll try TCP server. Okay.
Chandra, just on the time check here, you've got about 40 minutes left. So you might want to skip some of this so you due to the issue you had with the UART, so you can make sure that part 2 is done fully.
Great. Yeah. Okay. Yeah. No problem. Thanks. So let's do maybe 1 or 2 here, and then do the OTA part, and then go to the next segment. Okay, that's more important. So I'm trying to run a TCP server application here. Okay, just the command is AT transmit or transfer test. Start TCP server. Okay, I need to start with the port number, which is 888, I would say, or 8. Okay. Okay, it started. Then you can see basically whether it started or not in the console. If if you want to debug a little bit, I'm doing a little bit hands-on here. If you type PS here, you can see so many processes, and as well as you can see here, there is a TCP server started. Okay, so that's a one indication, whether your AT commands are running, as well as your the process is kicking in. So once it is there, I would like to run the IO Ninja. Okay. IO Ninja provides you all the application support that you wanted instead of you host some servers and all. So there are no general public TCP servers installed or clients installed. So I'm using this one. Accept, evaluate. So since we started TCP server on our device, and I'm going to run this as a TCP client. Okay. New session, TCP connection socket. Okay. Okay, I got my TCP IO Ninja application running. So what I do is I'm a client, so I'm going to connect to the DS16200 running as a TCP server. So I need to know my IP address, which is 39 is my IP address, and then the port is 8888. So I'm going to connect to that. Okay, and then connect. That's it. Okay, see, it's connected, and you got an indication saying that, hey, there is a client connected with the IP address of 220. Now I can send a application, any messages. Basically, you got setup, end-to-end network setup is done, connection is made. You can send and communicate between those two entities. So here I'm going to say hello, TCP server. Okay, send. I'm sending from the client. And you will get an indication again on the AT command interface. It's always a notification with a transfer. It's a client. It's sending from this IP address, from this port, and then a hello TCP server. Okay, it's as simple as that. So you can also send comments or maybe information from server to the client using escape yes. So I would very quickly say that you need to press escape key and then yes. That's an indication to send, put it into data mode. Okay, and then you say size is, this is a TCP socket, so it's a ID is 5, and then I'm going to send 5 characters. Okay, and I'm going to send to the client IP address, which is 220, so 10.0.0.220, and the port number is 65284. Okay, and message is hello. Okay, so it's sent already. The moment I took 5 characters, and I see here the hello message came in here. Okay, so what I was demonstrating is just so simple to have a basic application up and running using AT commands. I am trying to skip. I would like to skip these two because they're also very basic. Running a TCP client and then UDP client similarly. So we would like to run one more here, maybe HTTP server application, and then see how that works out. Okay. Okay, coming back here, since we started TCP server, so I would like to do a restart. AT plus restart. Okay, that should basically restart the board and then come back into normal. So whenever the board restarts, you get init done. 0 means the UART is up and running. You can send AT commands. Okay. Now I would like to demonstrate this HTTP server part. So it's also very simple. You just run, let's try ATM, right? Let me make sure we have AT commands. Okay, now I switched on AT echo on. So AT plus network HTTP server. Okay, just one command, that's it. And it starts a server. And I can also show that, it's running. Now you can see it, there is hello world application running in. So, it said like it started. So let's run now a simple client, which is a browser here, okay? I will open my browser and then connect to that and then see whether I can communicate to the server. Okay, so it's HTTP colon. The port is same. So IP address is 10.10.0.0.39 index.html. Okay, let's see. Okay, sorry. I forgot one more command, which is AT plus network HTS. We need to set flag 1 so that it starts. So let's see. Yes. Okay, now we see it HTTP server. Okay, it's running now. So now we can open a browser. Okay. And I can do HTTP colon. I'm basically connecting the client server. Okay, 10.0.0.39 / index.html. Okay, see, my browser can connect to that device and then get the message, which is very basic HTTPS server running. So this is the message coming from the device. So you can see it, it's connected and I got a response from the HTTP server. Similarly, you can run HTTP client and GPio application. So since the time is a little bit short, so I would like to skip this GPio operation also. It's the same. If you execute those commands and connect the LED, you can operate GPIOs also. Okay, I'm going to do the next part, which is over the air update. So as
we've
we
got
support
30 minutes left, Chandler.
Okay. Thank you. And I will do this one and we'll go to the next segment 3. So let's quickly do this OTA update on our device. Okay, I will copy paste directly the links that are shared already. So you can use the same links and then do this. So we do provide actually, like I mentioned, OTA update using AT command. So just run this one. Okay, so it's starting. It's checking the firmware. Whenever we do OTA, we need to do several checks, make sure it's the right firmware, authenticated firmware, signed, and also there are so many things goes on. But once it validates, it downloads the content and then validates and then uses the latest or updated firmware. So it's downloading it, 30% done. So we have 2 commands for that. One is you need to start. You need to download images. We supply 2 images. One is RTOS, another is slib. The slib is a binary. It always comes from us as a binary file. Whereas the RTOS image, you can generate that using our SDK. You can compile, and once you compile, you get that image generated. So right now we are downloading the RTOS image, if you see it here, okay? And once it downloads, then we can download the other file, which is the slib file. You can also see the same files in your supplied image folder also. If you download the AWS IoT SDK, you'll find those images there. Okay, it's almost 96, 98%, so done. Okay, the first one is done. and you got the notification. It's completed. So I will do the next one, which is the slib file. Okay. And by the way, if you see it, I'm doing it from AWS IoT, which is I'm downloading from the cloud. It's not like a local server or anything. You can do the OTA using any server. So most probably the next segment, which actually concentrates on AWS. So I'm downloading images from there. Okay, this is also done. Then we just need to run the AT command to update it. So that is AT plus network OTA renew. Okay, that will basically renew the firmware, and then it will reboot automatically. Okay, great. See, it's done. It's it now changes the version from the previous Dev Summit to AWS IoT reference. Okay, like to put in factory just to make sure we remove all the settings on the board. Okay, we are good. So that's how that's where I would like to end the segment 2 and move to the segment 3. And if you have any questions for segment 2, please post it on the forum or on the chat window. In the segment 3, like I mentioned, we will be covering mostly on the AWS IoT door lock application using our AT command set. Again, I will go through the command set information, how implemented, and what command set you need to use to implement your own AWS IoT based sensor. Right now, we are using door lock application. And also I will give you first the demo, and then we'll go through the code of MCU where it will be sending the AT command. So that's where you need the E-Square Studio and then the Wi-Fi shield, of course, the board. And I'm going to go through the AT commands implementation. Okay. Again, this is a very quick overview. Like these are the boards you should use here: MCU, SparkOne board, and Pico board. Okay, and the important one is I think you need to have Android mobile phone or tablet, and you should install the app that we shared to you. And this is a connection. I'm going to switch quickly because I do have one more board. So this board has a little bit more extension. So instead of using the same board, I'm going to use this one and then and use that. Okay. Hopefully this should be faster, disconnecting and connecting. So I'm going to now need to place this one on the MCU. So I'm going to disconnect this one. Okay. Place this side. I just need only a few connections. So, okay. Then, okay, done. I'm going to place this one on my MCU board. And then since we are placing it, so we just need to have UART communication, which is, these are two connecting here. Okay, here. That's there. And then I need to use this one. Okay, this is the UART and UART TX. So what's coming here? First one. Okay. I can fab in out, but yeah, that's okay. Okay, this is okay. One is here. Well, I'm connecting it properly. And then this is the ground. Ground is already there, so let's put it at ground. And then we need to have two UART1 and UART2 from this. So I'm going to use the Pico boards connection. So this is the sixth one, I'm right. 6, 7, 7. Goes to that down. Okay, one. Then the second one is Okay, and this goes to here. I'm done with the connections. Okay, so I have connected the Pico board like I mentioned, and then placed the MCU board, the shield board on the MCU. Okay. Hopefully everything should be good. And also please make sure you switch this one to hardware mode because we are going to use the interface through Renesas MCU. So I moved this one to hardware. Okay, and then first plug in the UART and then plug in now the MCU power supply. Okay, good. Let's see. Okay, great. I can see the activity on the console, which is a very good indication. I don't have any problem with my connections. And also, we should also see this one, UART one. And I need to have open one more. Let me open one more just to keep you. So the third one is we are capturing one for TX and another for RX. So that's why we kept it separate. We are monitoring the activity between the MCU and the 16200. Okay, again, serial port 150. Okay, hopefully it's very small, but okay. Okay, great. Okay, let's I'll show you the presentation a little bit. So we are here, am I right? We got everything done, hardware and software setup. We have the Pico board and then laptop for running the application. Means I will be showing some few of them, the mobile phone screen and all. Teraterm, we have pre-built images, we downloaded as part of the OTA, and we do have internet setup. So everything is there. So let's start. First part is I would like to go and show you the demo. Then I would like to go through the commands and then go to the code, and then we update the code and then see how that works. Okay. Okay. I need to share now my mobile phone. I am sharing my mobile phone screen. Just give me a second. Okay. This is my mobile phone. Okay, I install my app. Okay, again, come back here. Hopefully I'm sharing my screen as well as the camera, everything. Okay, great. So for the demo part, we need these three. So I'm keeping these three things. Okay, let's first start the reset. Okay, plug in that. Okay. I'm basically doing a factory reset by pressing the GPIO 7 button, which is marked on the shield board. You see it, there is a counter going down and then it's in reset mode. See, now we can see it. It's going into the reset mode. Not done yet. Okay. Okay, 5, 4, 3, 2, 1. Okay, factory reset ready. Okay, now it's better. Okay, now it's in the provisioning mode. Okay, I'm going to open my app. Okay, you can see it here. Okay, I'm going to provision this. So I will explain all these things, once I show you the functionality, because that's important to understand. So I'm connecting to that device. So the moment I connect the mobile phone here, it said that there is a client connected here on the console. Okay. So we are in a soft API mode and we are connecting the mobile phone as a client and doing the provisioning. So I'm providing the information of the access point. So when I scan, so I got my access point. I'm selecting that. and I'm going to provide the passphrase. Okay. Okay, hope I entered it correctly. Let's see, make sure I don't want to spend more time. Okay, good. So we are pushing the credential using the mobile app to the device so that it gets access point credentials and it can connect, as well as the mobile app will also get the AWS IoT thing related information from the device. So we got the thing related information, and now what we do is what the devices are doing is my mobile phone is trying to connect the AWS IoT cloud server that based on information it received as part of the provisioning or setup phase. And also the device, which is our door lock, is also trying to connect to the server and then set that thing information there. So if you see it here, everything is connected. It went into sleep mode. That's why you see it. It means it's completely powered and it's in sleep 3 mode. We are consuming somewhere around 3.5 microamperes. And if you see it on mobile phone also, you have AWS IoT cloud server, cloud connection is ready, as well as device is ready, means you can operate from the mobile phone. I can do that from here. You can use that closed door. Now you can see that message is immediately picked up by the device, and then it is turning on, it's closed the door, means you can see this LED here operation wise is now off. Okay. Now let's that's our overall, I just want to show functionality. Now let's go to the slides and then explain what's going on. Okay, this is the information I'm sharing. You can basically take this and then learn more from the user guide as well as from the slide deck. So we have set of 80 commands classified into different things. So the 80 command to set the basic interface between the 16200 module and our MCU is here. So you need to use either SPI or SDIO or UART. In this case, we are using UART. You need to use that pin muxing here. Okay. And you use these commands, AWS AT plus AWS with the set command to define the interface here. Okay. And then the next set of command is to set the AWS IoT thing or cloud MQTT related information. So you need to set the thing name, broker IP address, and then topic, subtopic, and what you're subscribing or publishing. And also you are going to set the sleep parameters, whether you are using how long you want to use. You want to use DTIM 1 or DTIM 3 or 3 seconds, 5 seconds, whatever, along with the DPM parameters here. So these are the set of commands that you need to run or call to configure the AWS related as well as the sleep mode related parameters. Okay, the next set of commands are sending the certificates. You need to have root CA, of course, private key and public key. So you are going to transmit those to the 16200 using this /x1b. So you can use that to transmit the certificates. Okay. Again, we are using AP commands and sending that information to the 16200. That's why if you see it here, it's always MC to 16200. Okay. The next command is configuration command, means we have set everything. We provided all the information that is related to cloud as well as layer 2 sleep modes. Now we can operate the device name, right, using the config command. So you can do a publish, you can do a subscribe. Also, you can update the shadow information using this one, CFG command. Okay, and examples are there here. You can refer them later. And the next one is like private commands, I would say, means it's between MCU and the 16200, where you can do a factory reset or get status of the 16200, what's happening, and you can also restart. Okay. Okay, these are the status responses for those commands. You get it. Okay. Okay, going to the next one. This again, same similar data. You can send the data to server. The part 2, where I will be covering mostly how you can implement, how the MCU can implement the AT commands and send this one. So in this part, I'm going to show you, or I'm going to explain what things are there here in my setup, as well as how we kind of implemented on the Renesas MCU, the whole AWS IoT door lock application. Other than that interface, I would like to bring in two things. when we have communication over UART, we need to have two interrupt signals between them. One, both can go into sleep mode. 16200 goes into sleep, then MCU has to wake up. So we use RTC wake up pin here to wake up 16200 from sleep if whenever the MCU want to interact. Similarly, we use GPIO A11 to wake up the MCU or indicate the MCU that, you know, if there is some data from the cloud to be processed. So that's indication, I would say. Other than that, we are going to use a standard UART communication, which using the hardware TX and RX. Please make sure you change the switch here, okay? Again, what we are having is we have full-fledged a solution from Renesas where you can turn on any application on AWS IoT Cloud within a very few hours, okay? You have the Renesas MCU, we have the module Spark on board, and then you have the AWS IoT Cloud and application. And also hope you all got the AWS IoT thing name, because every device will be identified with a specific thing name. So you should use that thing name when you change the configuration. I'm going to show that. Okay, this is standard how, maybe I'll explain more on the next, but basically what we are doing, what we are showing is what is the publish, how we are subscribing, what message, what is the subscriber message, as well as what is the publish messages. Okay, the whole application was implemented based on 3 state machines. One is the setting mode, where we send the set commands. And once we set those configuration, then we go into provisioning mode, where it will be like having all the configuration and ready to be provisioned. We use a mobile phone to pass this state. Once provisioned, we go into the communication mode. We have seen that in the demo that I did quickly, but I'm going to show you again. Okay.
You've got just about 10 minutes left, unfortunately. So
okay, let me try this. So in the set mode, you can see, once in this mode, you are going to send all the AWS set commands. Okay. These are the set commands we have implemented in the eSquare Studio or SDK that I'm going to show very quickly. So these are the set commands we have to call, and please make sure you need to change the thing name here in the SDK, which is implemented in atcommand.c file and header files. Okay, and then these are the GPIO command or pins that we are going to use it. In the configuration wise, we have some subscription. If you see it here, always mobile will subscribe or publish, and then door will subscribe, or door will publish and mobile will subscribe. So you'll see pairs of that. So see app door, which means mobile app is actually subscribing to that, whereas MCU door is actually publishing it, the status of that. Okay, similarly you can see all these things. Okay. Once we are in provisioning mode, you basically send all this information using mobile phone, and then we'll be into the going to the communication mode state. In the communication mode, of course, all the 3 entities are in a communicating mobile phone, and then device, and AWS IoT. All. So you can basically have communication messages, whether you can operate the door on and off, or maybe open, close from the mobile phone as well as from the MCU. Okay, this is more detailed information of message exchanges between each entity. Okay. I'm going to skip this one, and let's go to the eSquare Studio, how it's been implemented. Okay, open eSquare Studio. Hope you have downloaded the eSquare Studio, and it's ready. And also you downloaded the SDK. Please go to the SDK, you extract the SDK, and please go to the MCU section, where you'll have all the SDK for MCU, means Renesas eSquare Studio. There is a workspace. You can basically import that workspace and modify that. Okay, I need to share it, but it's okay. I'm going to share this one. Okay. Here I am. I already imported the workspace. Okay, you should basically, once you import, you should see something like this. This is SparkFun RA2L1. Okay, this is a workspace for this AWS IoT Cloud door lock application. So if you go to source, you'll find that atcommand.c file, which actually has all the information as well as the function that we implemented. The state machine is here. You can see based on the status, we are calling different messages and sending it. So you can go through that code and then understand it. The number one thing you need to change is you need to change this in door lock font. Okay, let us change. I'm going to use my own ID, so I'm going to change it. Dialog IoT 1. Okay, and I changed my code, as well as I need to change one more. I'm combining two things. Okay, one more is command details. Okay. We actually commented out the LED operation, so you don't see the LED operation right now. So I'm going to disable that and then upload that MCU code so that we don't see LED operation. Okay, and then we will enable and then see the LEDs are working on the board. So I only changed the thing name. Okay, if you see it here, I changed the thing name, and then I compile. Okay, build error. So let's see. I think it's because let's generate this one. Is it okay if we cross few minutes maybe?
I think you should try to finish as much as you can.
Mm-hmm. So I'm doing basically, I'm generating the configuration file because there are some errors here. Oh, why this? What is the version? I'm using the old one.
Yes, this is the old one.
Oh, do you know how we can switch in? Because we installed it morning and we tried it. Okay, let me see.
You should have the new one link somewhere.
Okay, let's see. Okay, program files. Can you, Paolo, can you tell me where will be that link? Because it's, I just want to search for that, I have multiple EastQuest Studio installed, so sorry for that.
And do you have a link in the desktop? Maybe there?
Sorry. No. But let me go to program files and find it out. It's a little bit hiccups are there. So, okay, program files. Okay, to search EastQuest Studio. It's not 2010, it's not coming up. So do you have any quick information, Paolo? Paolo?
Yeah, I'm checking as well. Just a second.
Okay. It's started. Oh. Okay. Basically.
Okay, if you go in C,
Uh-huh.
Renesas, RA, then you should have two folders, eSquare Studio, the old one and the new one. And then you go to the new one and then that's the Eclipse.
RA and eSquare Studio, which one? We should go for RA? Eclipse.
Yeah, I put the path on the chat.
Okay. So you said like eSquare, Renesas, eSquare Studio, and Eclipse.
C,
or...
Renesas, RA, eSquare C.
Okay. Okay, hopefully I got it now. Yeah, okay. Okay, yeah, I got it. Thank you.
Welcome.
Yeah, I was using the older version, but we just prepared everything for the latest version. So we thought to keep everybody on the latest version. So okay,
you're almost out of time now. So yeah, so make sure that you focus on the right things.
Yes. So let's change that window appearance perspective C++ so that we know project wise. Okay, what I was telling you is we update this source code. Okay, Commander C. Just want to make sure I updated. So I updated this dialog IoT 1, and then and also I want to disable the LED green. Okay, it's pin 4. Okay, door open. Okay, great. So let's compile it. Okay, build it. Like I mentioned, all the implementation is in the atcommand.c. Okay, if you go through that, you see that atcommand that we are going to use set commands and then config commands. Okay, and then this is DPM or sleep mode commands, and then these are the certificate information that we are communicating with the cloud server. And if you go down here, this is a while loop, and you'll have the state machine as well as implementation here. Okay. Let's see, it's built 0 error. So let's push that to board. Okay. I'm pushing the firmware to the board. Okay, great. Okay, let's start this one. So you can see basically, it is been configuring it. So let's get to it. Okay. Now we should see it here. You can see all the messages coming in here. It's configuring it. Now what I'm going to show is, it's we compile the code, we push the code to the MCU. Now we should see the LEDs doesn't work. Okay, that's the part which we are doing it. Okay, let's do the factory reset so that everything is erased and then got the latest settings from the MCU, which is a thing ID and the disable one. Okay, factory reset, and I'm going to share my AWS IoT app also. Okay. Okay, it's ready, and I will show you the mobile app. Okay, click here. Provisioning. Okay, then start scanning, and okay, testing. It should basically scan and be in that mode. That means the IT commands didn't work well. Okay. Okay, I'm plugging in and pushing it again. The default state is it should basically get all this command from the MCU, and then it should scan and wait for the provisioning mode. That's a second state, as I explained. State 1 is basically getting the information from the MCU. Okay. Okay, here is the one that right now it got all the information from the MCU as well as it scanning and waiting for the provisioning. Now I will show you again what's on the mobile app. Okay, so start.
Yeah, so Chandler, this is the last bit. You've got probably 3 to 5 minutes left to just show this demo, and then we have to update everybody afterwards.
Okay, yeah. Let's quickly go select. Okay, okay, it's connected, and okay, let's scan again. Okay, I see my access point, so I'm going to provision again 3562. Okay, I'm getting it. Okay, I pushed the credentials as well as I got the update from the device to the mobile phone. So mobile phone will try to connect the thing. Then, okay, this is successfully connected, and also you can see the mobile phone is trying to communicate with the cloud, and also get status. So since it went into sleep, it may take a little bit time, but let's see. Okay.
I think if it's connected there, Chandra, that might be a good place to break. We just got there. I think we do have it working. Just
right.
Yeah. Well, thank you very much, Chandra. That was we almost got there, but we managed to squeeze a lot of detail in there. Thank you, Chandra, a lot, and for helping our interactive guests and our attendees for making this such a wonderful workshop. And the workshop has been recorded and will be available on demand on the Dev Summit platform in hopefully a day or two. In the meantime, please explore the available content and enjoy the last day of Dev Summit. So, good evening or good day for now. We'll see you later. Bye.
Bye. Thanks so much. Apologies for the break.